Two fractions. We're finally going to do what you have wanted to do since we started this.
Not do any math.
And I mentioned it since we started this chapter. If you have nothing but two fractions that equal each other and you need to solve for x, tell me what you think you could do. It's what, yes, that's y'all's answer every time you see a fraction. Cross multiply, and in this case, it works. Okay, so we're gonna cross. This one is.
Which one of y'all?
But is this the whole section? No, I'm sorry. This is actually, in my opinion, a little bit harder than the other part, but we'll see what y'all think. All right, so when you cross multiply, you're not straight across, you're going at a diagonal. So 3 times 4x plus 5 equals 9 times x plus 1.
You don't put them in fractions again?
No. Cross multiplying gets them out of fractions. I hope at this point this is an equation that you all can solve. What would you do?
Distribute.
Ben's on it.
Yeah, boy.
Now what would you do? Get the variables together. I'm going to go ahead and move this 15 too, so that the 9s are gone, the 15s are gone. So over here I have 3x equals negative, what's 9 minus 15?
Negative 6.
Negative 6. So what is x?
Negative 32.
Woo! Keep shouting out the numbers. You'll get there eventually. Negative 2. Does that make sense to everybody?
Why you say that?
That's it when there's just two fractions. I'm not going to spend a long time on it because it's fairly easy.
Why did you subtract some?
This is the last.
Or did you just combine?
Yeah.
This is the easiest one.
Last section ever.
Is it the easiest one or is it?
Wait, this is
When there's I had this.
You combine the two on the left and then cross multiply.
Okay, so I heard combine the two on the left and then cross multiply, and I could do that. Would you
Or cross
agree?
multiply and then
They all have the same.
What do you say, Mackenzie? You could do that. And essentially what's happening when you do that, you're doing, y'all are both, if you put both of y'all's ideas together, y'all are
take
on
off
it.
the 5s.
So, because the denominators are the same, Mackenzie said multiply by 5, and she's right. David said drop the 5, and he's also right, because what happens when you do the whole thing by 5,
You get that. Or you get
right?
Yes.
So essentially, when the denominators are the same, as long as they're exactly the same, let's just get rid of them and set the numerators equal. Does that make sense to you, why? Okay, so I get 2x plus 3 plus x equals x minus 8. So, but the key is that all denominators are exactly the same. And I'm really stressing that because they're not going to be just a number down there, okay? We're going to have to LCD some of these things. Set numerators equal. So then,
Just solve it like normal.
yes, this would be 3x plus 3, x minus 8, and what would you do, Ben?
So you already, wait, what happened to that one?
I added it with that 2x that was in front.
5. I'd add 8 to that side,
Okay?
and then I would, wait, hold on. Yeah, alright, can you run over fast? I'm just taking my time, Matthew.
That's okay, go ahead. Carry on.
And then I have to get x on that other side.
Which x?
The one with the 3.
The one with the 3? So how you going to get it over there?
Divide by 3 or something like that. I can do it on the paper.
Do it on the paper and tell me what you did. You got 3x plus 11 equals x. What do I do?
Divide by 3 on each side.
I'm going to show you that scenario. I'm going to show you what to do.
Subtract 3x.
Alright, then 3x on that side.
Okay, so how do I get 3x on that side?
You subtract
So,
the 3x.
good job. You subtract the 3x.
Good work.
So I got 11 equals negative 2x. Now what do you do? Divide by the negative 2. So x is negative 11 over 2. Easy enough?
Sure.
That one was, right? Of course I'm not going to give you the same denominators. That would be much, much, much too easy. So let's look at one that does not. We'll start easy. Solve for x. So my goal here... Ooh, actually, let me not start with this one. Fine. Okay. So somebody said LCD it. That's exactly what I would do. I would say this is a whole number, so I'm going to put it over 1. So I'm going to find the LCD of all 3 fractions. Okay. What would the LCD be?
1x minus 5.
1x, x minus 5, right? So look at the first one. What is it missing? Everything, right? X, x minus 5. X, x minus 5. What is the second one missing?
X.
How about the last one?
X minus 5.
Is anybody confused on what we have done thus far? No. Are we all in agreement now that all the denominators are the same? Yes. So, let's get rid of them. So now if I have x times x minus 5 minus, watch those signs, 8x equals 3 times x minus 5, is this something you can solve?
Yeah, and then you just get rid of all the parentheses.
Yep, let's get rid of the parentheses, so let's distribute, x squared. There's the dreaded quadratic. So if I have a quadratic, I need to do what? Get everybody to the same side and see if I can factor it.
Why do you use a 5 on it?
Ah, it's 15. Yeah, thank you. So, negative 5 and negative 8 is negative 13. And now I'm going to move the 3x and the 15. So I have x squared minus 16x plus 15 equals 0. Does that factor? It absolutely does. You're right, Drew. 15 and 1. Both signs are minus, so I got x minus 15. X minus 1. That multiplies to 15 and adds to 16, yes? So my two solutions are 15 and 1. Yes? Hey, Sean, I don't know what you're talking about.
You basically saying it's confusing.
Remember, guys, before I find an LCD, I need to make sure I factor everything. In this case, look at that second fraction. Difference of 2 squares, right?
Oh, wait.
Okay. So now it makes a little more sense with the other denominators that I have there. So what is the LCD here?
That.
Exactly. The denominator of that second fraction, x plus 3, x minus 3.
Do they say equals 4x or minus 4x?
Minus.
I had them, but I ain't supposed to go on.
All right, what's the first one missing? X plus 3. What's this one missing, the second one? Nothing, it's good to go. How about the last one?
X minus 3.
Are we all in agreement that the denominators are now all the same? So drop them off. And let's expand this a little bit. Let's get rid of those parentheses. 6x plus 18 equals 8x squared minus 4x squared minus 12x.
Alrighty.
What to do? What to do? You tell me.
I guess get them all.
Like terms and make them equal 0 exactly. 8x squared negative 4x squared is 4x squared. And then I'm going to move these guys over.
Wait, you don't solve for x?
I am. That's what I'm getting to. So at this point, I could. What can I take out? 2.
Why don't you just put the x
So I
on
got
the side?
2x squared minus 9x minus 9. Why don't I do what?
Why don't you just pull the x's on that side? And get used to x.
What?
Because you got the squareds there. You have a quadratic. So as I look now,
Put it in the main box.
it doesn't look like that's going to factor, does it?
Wait, isn't it like it changes to negative 18 and then 63 or something? Or no, it wouldn't work.
It would have to be a negative and a positive so it would work because 6 and 3 would have to both be positive.
Oh, look, wait, we messed up right here.
63
I would have just
No,
put
they add them. I knew it.
Y'all didn't catch that.
Grace caught it, don't worry. Grace caught it.
Well, tell me next time, Grace.
I was wrong.
I thought I had one up here that would factor to start with, so whenever I got there, I was like, that's odd. I'm pretty sure I picked one that would factor.
What happened?
I was
When we distributed this negative 4x and negative times negatives are positive.
Yeah,
And we've
I
written
thought-
negative.
I just go with it.
I changed it. I was like, oh.
No, don't. I can be wrong sometimes, for sure. 6x, so this is going to be plus 3x. Now, what multiplies to negative 18 but adds to positive 3?
Negative 3, 6.
Yeah, negative 6 or negative 3 and 6.
Negative 3 and 6. So now I have x, 3, 2x, negative 3. Wow, that was blowing my mind for a minute.
We can do it again.
Rookie mistake. Rookie mistake.
Is that your final answer?
No, because I need to know what x equals. So what does x equal?
You can divide by
Divide by 2.
Which is not really going to do anything.
You're right.
So negative 3 from this one.
And negative 2/3.
Well, you'd add 3 and divide by 2, so it'd be
Yeah.
positive. Tell me what you think. That one's a little bit hard.